Another quick example using nodal analysis. In this one, we're given a simple circuit, and we're asked to calculate the current Ix, which that's this value right here, flowing through that 4 ohm resistor. So here we're going to use nodal analysis to determine what that is. So let's take a look at this. So the first thing we want to note is we really have two nodes of interest here, right? So this right here we'll call node A. So we'll designate the voltage at that node then is VA. And then we have another major node right here, and we will designate voltage there as VB. And so let's see if we can create our system of equations now using this. So we'll start with node A. And looking at node A, the first thing we note is, again, we're finding current leaving the node is positive. So we have this current source right here, and it is entering the node, shown as entering the node. So then that will be a negative 6 amps. And so then as we work down here a little bit, we have this resistor here, 10 ohm resistor. So again, just using Ohm's law, the current in there is going to be VA over 10. And then next we're going to see this resistor here. And when we look at that one, that's going to be the difference in the voltages, VA minus VB, over the resistance, 4 ohms. And then finally, we have this resistor here. And so when we go to characterize that, that's going to be, again, the difference in the voltages, VA minus VB. It's the same nodes, over 2. So now that's all of the branches going in and out of the VA node. So then we should be able to set those equal to 0. And so now we want to go back and look at our B node. And so when we do that, we already have the resistor in purple defined, so we can characterize that current. So in this case, it'll be VB minus VA divided by that resistance, which is 2. And again, we have the green one that's already highlighted for us, the 4 ohm resistor. So that's going to be plus VB minus VA over 4. All right, and so next we're going to have this resistor, like this 3 ohm resistor right here. And so when we characterize that, that's going to be VB minus 12 volts, because we have that 12 volt source, over the 3 ohm resistor. And then finally, we're going to have this 5 ohm resistor here. And so to characterize that, that's just going to be VB over 5. And so we set that equal to 0. So now we have our two equations and basically two unknowns. And so if we multiply through and gather like terms, we can rewrite this then. So this top one will end up being 0.85 VA minus 0.75 VB, and that's going to be equal to 6. And then same thing if we do here, if we multiply through, do all the division and gather all our like terms, we'll come up with a minus 0.75 VA, and it's going to be plus 1.28 VB, and that's going to equal to 4. So there's our two equations, two unknowns. So then, just drawing a line here, we should be able to create a matrix then of 0.85 minus 0.75 minus 0.75, 1.28. That's going to be times VA, VB, and then that's going to be equal to 6 and 4. So again, now we're using our scientific calculator. If we were to take this array and divide this into this, what we'll come up with then is VA is equal to 20.15 volts, that's VA, and VB then would be equal to 14.91 volts. So having those voltages, now we should be able to determine what IX is, right? So IX is just the current in the 4 ohm resistor, and so that should be equal to VB, minus VA divided by the 4 ohm resistor. So the difference in the voltages, and we're showing VA minus VB. Remember, we're calculating this IX, and we're showing it going from BE to VB to VA, so we're assuming VB would be the higher node. It may be a wrong assumption, but that's the way it's drawn, so we have to go with that. The signs will correct it if it's not. And so then this will be 14.9. Oh, sorry. I miswrote this. This is 14.91 volts. So 14.91 volts minus 20.15 volts divided by 4. And we should be able to see then that this is going to be negative, so it's a negative 1.31 amps. And so the negative sign tells us that our assumed direction is wrong. It's actually going the other direction. That's okay. I mean, the signs work out, and that's what that tells us. So we solved for the voltages using our system of equations, and we used that to come up with what they were looking for was the current flowing between VB and VA.